Section 5.2 deals with defining slope. We're going to have two learning targets for today. We want to be able to calculate the slope of a line using rise and run. And second, we're going to calculate the slope of a line from the ratio and the differences of the y and x coordinates. There's a much easier way to say this. We're going to use the formula. There's a formula that helps us find slope. So let's get started. The first thing we need to talk about is the fact that slopes can be positive, negative, zero, or undefined. So we can have a positive slope. I hope I use the right colors here. Okay, if our y values are increasing from left to right, we always read slope from left to right. We can have a negative slope. That's when our y values are decreasing from left to right. We can have a slope of 0, which is any horizontal line. And we can have a undefined slope, which is any vertical line. So slope can be positive, negative, 0, or undefined. To help you remember that, I suggest that you Google slope dude. There's a great video on YouTube called Slope Dude. Check it out. Now, we like to define slope as the ratio of vertical rise to horizontal run. Let's see what we're talking about there. So, we are going to define slope, in this case, as we're going to say slope is equal to rise over run. All right, slope is equal to rise over run. Here's what I mean by that. If we look at a line, let's take this first example, for instance, and we pick 2 points. So we have this point and this point. We can calculate the slope by looking at those 2 points and counting how to get there using our coordinates. So if we start at the first point, to get to the second point, we would need to rise 1. So in this case, our slope, which we said is equal to rise over run. Our rise is 1, and our run would be 1, 2. So our slope is 1/2. Now this will work for any of the points we pick on that line. If we don't even pick the 2 points that they're looking at. Whoops. If we don't even look at those 2 points, let's look at 2 of the other points. There we go. So instead of using the points they use, let's use this point and, I don't know, this point. Say those are the 2 we picked. And let's count the rise and run between them. So let's do it. To get from here to here, I'd have to rise 1, 2, 3, 4. So in this case, my rise is 4. My run would be 1, 2, 3, 4, 5, 6, 7, 8. 4 over 8, which reduces to 1/2. So the point is you can pick any 2 points on the line. As long as you count the rise and the run correctly and you reduce the fraction correctly, you should end up with the correct answer. Let's look at our other example. Whoa, 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 whoa. So in this case, so again, slope is equal to rise over run. In this case, to get from this point to this point, I'm going to have to go down. So we say that we are rising -1, -2. Our slope is actually, or I'm sorry, our rise is actually -2. Our run is +1, +2. -2 over -1 equals -1. So our slope in this case is just -1. So it is possible that our rise or our run even is negative. So that's one way to calculate slope. Count the rise and run between 2 points. Another way is to use the formula. Now here's the formula. M is equal to y2 minus y1 over x2 minus x1. And before you get all worried about what the heck are those x with the little 1s and the y with the little 2, those are just labels. And those are labels for our points. We're going to have a point that is x1 and y1. We're going to have a point that is x2 and y2. They're just labels. So let's go ahead and do that. On this line over here, we have 2 points. Our first point is -1, 2, 3, -1, 2, 3. So -3, -3. Our second point is -2, 1. And we assign the same labels. So we're going to call this first ordered pair x1 and y1. And the second ordered pair x2 and y2. Let's plug everything in. So let's start on the top. Y2, our second y value is 1. So I'll plug that in. Whoops. 1. Minus y1, our first y value is -3. Then we go down to our x values. Our second x value is -2. And our first x value is -3. So now it's just about doing the math correctly. 1 minus a -3, be very careful, actually equals 4. And -2 minus a -3 is equal to 1. So our slope in this case is 4 over 1, which it's fine to leave it. That answer left like that is just fine. Or you could also write it as 4. This formula must be memorized. Memorize that formula. You're going to need that. Know how to use it. The last thing I want to talk about is horizontal and vertical lines. All right? Now, if you went and watched that Slope Dude video already, great. If you haven't, go back and watch it. Because Slope Dude, let me write that one more time. Slope Dude, Google it, I'm telling you. We'll tell you exactly what you need to know for this. But here's what you need to know. So like I said, we have positive lines, lines that rise from left to right. We have negative sloped lines, lines that fall from left to right. They're y, so on a positive slope, the y values are increasing from left to right. On a negative slope, the y values are decreasing from left to right. What if those y values don't change? What if those y values don't change? Meaning the line is just horizontal. Y values not change. The slope of this line is 0. And the reason is, if we remember that slope is rise over run, in this case, since my y value isn't changing, the rise is always just going to be the rise is just always going to be 0. And we can calculate any run. We can take any, doesn't matter how far we take for the run. But since our rise is 0 and our run is going to be some number, it means our slope will always be 0. On the other hand, if we have a line that goes straight up and down, in this case, our rise is going to be any value we want it to be, but our run is going to be 0. Okay? Since we're trying to divide by 0, which is not possible, we say that this slope is undefined. So if you have a vertical slope, vertical line, I'm sorry, a horizontal slope, a horizontal line, we say that the slope is 0. And if we have a vertical line, we say that the slope is undefined.